All right.
So, did you take a look at today's agenda? All of you, I don't know if you got a chance. If you did not, we are going to introduce a new topic in today's session, how to use the Git and GitHub. So, is anyone of you familiar with what is GitHub or Git is?
I'm aware with what GitHub is. I've used it with website stuff.
Okay, can you explain what it is in like one or two lines?
Um, Basically, like you can have different repositories, and you can hold your HTML files and JavaScript and CSS.
Mm-hmm.
Um,
Okay. Yeah. So what basically Anya was referring to is it's nothing but basically it's GitHub is a storage for your files and data. So, and Git is a tool that you install on your local to interact with this storage for your files on cloud. I'm going to share two links with you on the chat. You need not have to go ahead and start the installation right away. I'll send this on Slack again. I think Josh shared one of them on Slack already, but I'll share both of them. So these two links, what they will take you through. So let me open and share my screen. Can you see my screen?
yes.
Do you see how to install and use Git on Windows?
Yeah.
Okay, perfect. So this is the link that will walk you through the setup, how to install Git on your machine. So you can follow the steps which are listed here one by one to get it installed on your machine. And then the second link that I have is for creating a GitHub account. So you can follow the steps which are listed here to create a GitHub account. And once your setup is complete, I think we are going to have one more session. Once your setup is complete, we can walk you through different commands that we use from your either from the command line tool, like the command that you can execute on your prompt, or we can integrate this tool with your IDE, IntelliJ IDE that you use for programming, and we can show you how you can add the files to the Git repository, how you can update it in the Git repository, and also how you can collaborate more. So just to give you an high level information on what it is, uh, have you ever run into a scenario where you updated a file and you wanted to share that with your friends, saying that, hey, this is the code change that I have done, and you can integrate with whatever code that you have on their own machine? Have you ever ran into this scenario during your FTC or FRC coding exercises, or while you're coding for it?
We have run into it on the exercises, Richa. So,
They are.
I mean, so they send it to me through Slack, right? So,
Right. Yeah, that is also one of the examples. So basically, this is what it looks like. What you can do is once you create your GitHub account, you will create a new repository. So basically, I have created an organization for myself. You can create a new organization here. It will walk you through all that setup while you're creating an account. And then I can say that test repo. I'll go ahead. So basically, the public repositories which are free, you have to pay for creating the private repositories. So for your exercises, what I will say is you can go ahead with your repository as a public one, and then you can click on create repository. What this will end up doing is it will create a folder like structure for you to start storing your files on here. You can work on adding collaborators. So I can go ahead and look for Ram here. I don't know, Ram, what is your Yeah, there you go. So I can say that Ram is on my team and I want to share this with Ram. And I can say Ram can only read, or Ram can write, or Ram can do a lot of stuff on this repository. So there are different settings that you can do when you add a user to your repository. As far as the code is concerned, so these are different commands that it tells you how you can
Hmm.
now integrate this cloud-based folder with a folder on your local machine. So there are certain steps that you have to follow for doing it, and we can go over these once you have the setup on your local machine, or if you end up getting till this point, you can try running these on your command prompt, but make sure that you have Git installed on your machine. So finish the first two steps that I have mentioned in the or the link that I have shared with you. Go through that. Once that setup is complete, create a test repository here and then follow these commands. If you have questions, you can reach out on Slack, or we can take a look at it. So basically what it helps with is, say I am working on a file and I'm creating multiple versions of the file. Say I'm creating test file, okay, and then I save it as a test file. This is my very first version of my file, right? I saved it. Now I want to make a change, but I do not want to lose what was here. So what I will end up doing is file, save as, right? And then I'll create a different version of this file. And then I'll click on save, and then I'll make changes here saying that test file 1. So to maintain the history of changes, whatever you are doing, this is how you will end up creating like multiple files, like test file and then the test file 1, and you will say that, hey, this is my version, and then you will share that with your friend. But with Git, what happens is, once you have your repository created, you can add a file to your repository. So I'm going to go and then take a look at one other projects that I have. So basically, what I can do is, say I have all these multiple files underneath here, and then I can keep on making changes and keep on adding that file here. So the action that we take is called as committing to the repository. So basically that change you are committing to your repository to push that change under the same file into your folder. And if you take a look at the version control that is integrated with your file, it tells you the entire history, what has happened. So basically you will see that these are all the changes that you have been doing on your file, and you are going to maintain that in your repository. So tomorrow, like if Gracie added a change and she wants to share with her team member, so this is the line that I'm changing it to test 123. I can say that commit this change basically. So commit the file, and when I commit the file, you add a comment here basically saying that what the change is, and then you say commit and push. So this is through the UI that is integrated with your IDE. The similar thing that you can go to your command line and you can use your git command line git tool, and then you can carry out the similar set of commands through git commit. So we can go through this exercise next week, like how you can use different like different commands through your IDE or through your command line tools once you have the setup ready. Was it confusing? Are you clear on what it is? Any questions on it?
And Richa, maybe you will show this in a bit, like the history view, right? Maybe you
Yeah.
can show them on the web browser. Maybe it'll be a little bit more clearer if you show them on the web browser.
Okay, I can do that. All right, so are you referring to the commits? I'm
Yep.
trying to say which view you're talking about.
Yeah, is
Let
there
me
one
take
that
a
has
look
a lot
there.
more comments? Yeah,
Yeah, that's what I'm trying to do. Maybe not. I'll have to take one of our actual projects to show that.
yeah, that's fine too.
Let, let me change the organization. So this is an actual project that Ram and I work on daily basis. So you can see that so many different changes are done. And when you look at that, it tells you who did what change. And then it also lets you know, like, so this is what I was referring to as the comment that you add when you made a change on a file and you're trying to commit that to a repository. So this is the history view of each and everything that has been changed as a part of that code repository and on all the files, on multiple files. You also can take a look at, like, okay, something isn't working. Why is it not working? It was working before. So you have a way to see the difference between what was changed from the file version that is in the repository now from the previous version. So all those views are available for you. Also, as a part of this tool, what something is called as the basically the merge conflict. So what that means is, if I and Ram worked on the same file and we modified the same line in that file, it will tell you, like, whatever version is already out there. If you're trying to overwrite it, if you don't have the latest one that was used by other person, it will tell you that there is a issue with the file that you are trying to push. So that is something called as merge conflict. I'll be able to walk you through this in a better way once you have this set up on your local machines. Anything else, Ram, that you want to cover?
Yeah, I was going to show them. Maybe if you can click on one commit, Richa, and show
Okay.
them. Hey, yeah, like just if you can explain that, right? What is the red one and the green one?
Yeah, sure. I
Or
can
maybe
go
it's a
over.
little confusing. If you want to do it next week too, that's fine.
Yeah, that's what I was thinking, that once they have it ready and we can check in their project for the every team, and we
Okay,
can have each of them, try out all these commands. So I just wanted to give a quick introduction today, so that they can get started with their project, like the setup on their machines. And then next week we can again come back and take a look at it and try it out actually on their machines. That's
cool,
what my uh, thought was.
cool.
Okay. So I will post those links on Slack again on the Java channel, and then you can follow those. We can address any issues during the. Oh, now I hear thunders here too. Um, I guess everybody is too quiet. Was it too confusing?
No.
No.
Okay, that's good. All right, you want to move ahead, Ram, with the.
Yeah. So today we'll be talking about IMU or gyros. So there is a built-in gyro sensor. It's called IMU, and today we'll be talking about that. So before we get started on gyros, does anybody have any questions about the last week's content or the weeks prior? And I see we have Tyra on call today. Does anybody have any questions on the last week's content or any comments that they'd like to share with the others? All right, so I'm going to go ahead and share my screen. Does anybody want to take a stab at where do you use a gyro?
Um, do you use a gyro when you need to make like a precise turn or something?
Yep, that is correct. That is one reason. Any other reason?
Maybe specifically during autonomous mode?
good. Maybe can you elaborate a little bit more on that, autonomous mode and so I have a working, let's see, I have an example. Maybe let's take a look if this works or not, okay? So let me go ahead and run my program. Sometimes it'll work, sometimes it'll not, okay? So bear with me. And you can see where one of the reason we use the Garo. So on your simulators, I think the gyro is only available in the Mecanum robot, so that's what we will be using, okay? So I'm going to choose Mecanum, and then I'm going to run one of the exercises that I put in. So IMU prep, and then I'm going to generate some random error, okay, and create some friction, and let me go ahead and start the program. And let's see how this goes. You can kind of see here, this line, right, is not a straight line, So one of the reasons we use a gyro is in order to make sure that, you can go in a straight line. And the other example that you already gave is like, if you want to make sure that the angle, right, it turns a precise angle, And that I think isn't going to be an exercise for you. We'll kind of go ahead and see the basics of how to make sure that your robot can go in a straight line. But as for your exercise, I would like you to take that, whatever we do today, and see if you can implement a controlled turn based on what we learned today. Okay. Any questions on this this thing that I showed you here? And I'm basically just using an encoder, like how we discussed last time. It's just that I made sure that there's going to be a randomness, right? There's going to be some error. It could be that, one motor is basically one side, right, has more power than the other side, or there's more friction on one side, or, there are other factors that can go wrong with your robot, right? And you want your robot to go in a specified angle. The one way you can do it is consistently check what angle you're going, and if there is a deviation in your original angle, right, you can make the tweaks necessary. And the tweaks are basically you increment the power on one side, or you decrement the power on the other side, right? Something like that, And let me go ahead and run this exercise with the gyro code implemented, and you can see how this works, okay? All right, so we're going to do the same thing. I'm going to go ahead and put some randomness in the program. I'll go and show path, and then go ahead and select the exercise. And then do an init. Then start. You can kind of see the path now. It's almost a straight line, okay? And that's what your gyro is going to help you, So that's what we're going to implement today. Any questions on this? Anybody have you used a gyro before? Anybody from the class?
I've used a gyro sensor, but I used it in FLL, so.
Okay.
I have used IMU before. We used it last year.
All right. All right, Merlin. So you can correct me if I make some mistakes here, okay? Have you done, Merlin, have you done a control turn?
What?
I don't know who was talking. Was it Merlin or was somebody else?
Yeah, this
It
is
was
Merlin.
that was me.
Oh, yeah. Have you done a controlled 90-degree turn or like given an angle? Have you made a turn with gyros
Yeah, I
using
have.
gyro?
I
Okay.
have, but we haven't used JavaScript. Use blocks, FTC
Okay.
blocks.
Got it. Got it. So this should be kind of familiar to you then. Okay. So
Yeah.
let's go ahead and start writing the code. Before I start writing the code, any questions on what we're going to do? So to summarize, right, we're going to use a gyro and make sure it goes on a straight line. Like you have seen, right, if the robot, there is a chance due to inertia, due to difference in the power on both the robots, that your robot can deviate from the path, okay? So in order to fix that, we're going to use gyros. And as an exercise, right, I would like you to use what you learned today and see, based on clicking on the gamepad, clicking A or B, you can do a control right turn or a left turn. Okay, so you'll be using what you learned today and what you'll use in the last classes to see, can you make the changes necessary so that, once A is clicked, you do a right turn, or once B is clicked, you do a left turn. But you always look at the angle, right? And you have to keep turning until the angle is reached, okay? So you'll change the power of your motor, right? And you'll consistently check the angle. So if your angle is not reached, you continue to turn, right? So that's what is the exercise for you, okay? But we'll go and see how to put the code in to make sure that the robot goes in a straight line. And everybody can see my screen, right?
Yes.
Cool. So like we did last time, we'll go ahead and create a class. And we'll go ahead and do extends linear op mode. And then we need to go ahead and put our annotations in. So autonomous, we need a name and we need a group here. So for the group, I'm just going to use IMU. And for the name, is that. And when I ran this program, right, you could see that, let me just run this program just so that we can get the, what the variables are called, right? So you see in the mechanism bot, the motors are called back underscore right underscore motor, front underscore right underscore motor. So these are the variables. So we will need that to initialize. Right, so I'm going to basically paste them there. And also we need to see what our IMU sensor is called. Oops. I think that is pretty much it. All right, so we'll be using the mechanism motor for this because this on the simulator, the IMU sensor is only available on the mechanism motor, okay? So let's go ahead and put some pseudocode in first before we go ahead and write the actual code in. So here we will declare our motors, okay? Then we will initialize the motors, okay? Then we will set one side of the motors and we want to use encoders. So we'll go ahead and let's go ahead and say, hey, Let's go ahead and set the mode for the motors to use encoders. And the IMU sensor, it's a little challenging, a little tricky, but the code is going to be the same. So you need to initialize the parameters for the IMU. Okay. This is going to be a little challenging, but the code is going to be the same. So you just need to copy and paste whatever we put in here. After you initialize the parameters for the IMU, you need to set or initialize initialize your IMU with the parameters, and then since we have done all the initialization, then we wait for start, and then we start a while loop. So while op mode is active, the first thing we need to do here is get the current angle. Okay, this is what the IMU gives you. Right. So once you know your angle, we will say if angle is greater than 0, and we'll play with different angles, okay? But basically, this angle here is the angle the robot is heading in, or it's the initial angle that we choose that the robot should head in, okay? And if I'm saying that if the angle that is returned from the IMU, right, is greater than 0, that basically means there's a slight deviation, right? So let's say if I say angle is greater than 5, then that means that the angle is gone beyond 5 degrees, right? That's when you want to correct, okay? So this is basically the tolerance that you want. Okay? So if I basically want it to go in a perfect straight line, then I will basically say, hey, if it is greater than 0, right? So even if there's a slight deviation, then I want to basically set, or let me make this a little different. So if it is going slightly in one direction, so I will say increment power of left motors, okay? And else if angle is less than 0, that basically means if it's going in the other direction, right? You will, sorry about that, my phone is ringing. You'll increment the power of right motors. And similarly here, sorry. And if it's if the angle is equal to 0, any questions on the pseudocode that we put in? All right, so we declare our motors, then we initialize our motors, okay? Then you got to set one side of your motors to be in reverse. Then you set the mode of your motors to use encoders. We also want to initialize our IMU parameters and then basically set those IMU parameters to the IMU. You wait for your start, and while your op mode is active, you'll get the angle from the IMU, right? If the angle is greater than 0, right, you'll want to increment the power of one side of the motors and decrement the power of the other side of the motors, right? So let's say if you start off with the power of 0.3, you will increment the power of the left side by a small increment from 0.3, and the right side you'll decrement it by a little bit, right? Similarly, I'm going to do the same if it is less than 0, but I'm going to do the opposite side for the different motors. If the angle that is returned is 0, you don't want to do anything, right? You just simply want to set the power and keep going straight. So this can be thought of as my, I would say, the angle that is my tolerance angle, right? So if you think your tolerance is 1 degree, so, and then you can change this to 1 degree, right? So 1 degree, and here it'll be -1, right? So basically you're okay with your robot going plus or minus 1 degree angle either side, right? So that's your tolerance limit, okay? But I'm saying, hey, I do not want any deviation, so I'm going to go ahead and stick with 0, and you can play with this so that you can kind of see how your robot moves, okay? Any questions on the pseudocode before we actually go ahead and start putting our actual code in?
Why do you have to increment the power of left motors and decrement the power of right motors, or vice versa? Could you just increase one of them or decrease one of them, or do you have to do both?
I've never tried it, Isabella, to be frank. We can go ahead and try it after we put in the code in and see if it kind of works, I mean, it may be valid that you just do one side, right? Yeah, let's, after we put in the code, make it work, we'll basically, let's go ahead and see if we can do it only on one side and see how it works as well, okay? Does anybody have maybe a better answer, apart from me saying, just let's try it out, Cool. Yeah, we're going to learn through practice, so let's give it a shot. All right. So DC motor. I don't know if George is there. Maybe George can answer that question. Oops, George's not there, so. Oops. So we declared our motors here, and then we'll go ahead and start initializing our motors. So we'll say, So we got that part done. And let me go ahead and change these so that these are just consistent with this, so I can right click and say refactor and rename. So instead I'll call it front right motors just so that it's consistent there.
Wait, what?
And refactor all the other variables too. So say refactor, rename. And so we're going to call this and you can kind of see when I say refactor and rename, right? It also changes these variables at the top, right? Or it changes every single reference, okay?
My computer died. No, it's my phone. I am not. My last shit. Well, that. I can't get anything out.
Right. So we got that. I also need to go ahead and declare my IMU. So we'll go ahead and do that.
We're having IMU
Yeah.
senses.
Yep. I see there is, I think, Gracie, you may have to mute your, I don't know if it's Gracie or Isabella. All right. So, all right. So we initialized our motors, right? And then I need to basically now set some of the one side of the motors to go in reverse, right? So let's go ahead and do that. So we'll set our left motors to go in reverse. So we'll say back motor dot set direction, and then we'll say right. So we set the back motor. We'll also do the same for the front motor. Okay, we did that. Now let's go ahead and tell our motors that we're going to use the encoders. So all right, so we are done. I think we're done with the motors. So we have set the direction. We are basically saying, hey, go ahead and use the encoders. Now let's focus on the IMU as is. So we're going to initialize some parameters for the IMU. And for the simulator, the IMU is already calibrated. But if you're actually doing the actual robot, right, just remember that you need to do the calibration. And maybe I'll send you some articles, or I'll ask George if he can send you some articles. But in your the main program, you'll have to do some calibration, okay? So for the IMU, I said you have to initialize your parameters. So the way you do this, so there's a parameters here. So we're declaring a parameter variable, and we'll use the new to basically initialize our parameters. Okay. So there are two parameters that we will be initializing: the angle unit and the acceleration unit. Okay. So the angle unit which I'll talk in a bit here. So do you want to use degrees or radians, right? So that's one parameter that you need to initialize. And then what is the measurement, right? So the measurement is the acceleration unit. Oops. And we'll be using meters per second, okay? These are two parameters that you always have to initialize. And then since we have initialized the parameters for the IMU, then you can go ahead and set the parameters on the on your IMU, okay? But in addition to that, I think I need to initialize a logging parameter. For now, I'm going to just set that to false, you know. So this is just to get the telemetry data. Instead, we'll add our own telemetry things, okay? So we've initialized the IMU parameters. Then we'll need to initialize our IMU with these parameters. The way you do it is basically saying IMU. So let's go and initialize the IMU first, similar to how we did the motor initialization. So and it was called IMU. Okay. So you initialize your motor based on whatever you're setting on your robot will be, what you called it on your robot. After that, we can initialize our initial IMU with the parameters that we just created. Like I said, you know, this bit of code doesn't change. You can just pretty much copy and paste this, you know. So this is a little different from what others we did. So let's go ahead and add some telemetry code. So that should send it to our robot. And now we have to do wait to start. Okay. So once the user hits start, you can add telemetry code to say that it is running. Okay. And just so that I can watch this, you know, I'll go ahead and sleep for some time. Okay. So we've done that. So now let's go ahead and put our code. So it'll say while op mode is active. So we'll go ahead and start our while loop. So we need to get the angle first. So we'll say IMU dot get angular rotation, and you actually need to use this method, which takes some parameters. Okay, let me put them down and then I will explain them in a bit here. So first one, you have to give the axis reference. This axis reference is basically to say, is it an internal sensor or an external sensor? In our case, it's going to be an internal sensor, right? That's the first parameter. The second parameter is called when you get the angle back, right? Which angle do you want? Is it the X angle, Y angle, or the Z angle, right? So we always want the Z angle, and I will explain that in a bit. But for now, take it from me that, you know, you want to use the ZYX, okay? And this is basically kind of goes to how the plane moves. So when the plane moves, right, if the plane's direction has to change, right, it will basically go like this, you know. So that rotation, right, you know, your Z angle is normally pointing upward, straight upward. So when you want to see rotation around, right, you will basically rotate around your Z, okay? So that's why you want the ZYX. I mean, you can use XYZ too, but we'll use ZYX. And later we'll say, hey, because we're using ZYX, I need the first angle, okay? So if you use YZX, you know, you can say I want the second angle, okay? But from a rotational aspect, right, you always want the Z angle. Okay, that's the takeaway from this. And the third one, I need to set which unit I want it in. So I'm going to say angle. So this is basically the call to the IMU, and this would give me the current angle. Okay, so we're going to call this heading. I've not initialized the angle yet, so let me go ahead and initialize that first. Okay, the way we're going to do this, it's called orientation. Orientation, and let's say heading. So this one will basically hold the current angle. Okay, and the way we initialize this current angle or the heading angle is you get it from your IMU, and that's how you initialize this. Any question on this line of code here? So this is basically giving you for the IMU, right? What's the current angle that is pointing towards? All right, so we got that. Once we have a heading angle, then it is pretty simple, right? We just got to put our if conditions to say if heading angle, let's say if to start off with, right, we'll say, hey, we do not want any deviation. Okay, so we'll say if heading angle greater than 0, I think I need to do one thing more here. I need to say first angle. And like the reason we do first angle is because we said, once we get data from this angular orientation, right, it has three angles, X angle, Y angle, and Z angle. Since we said the order is Z, Y, X, and we always want the Z angle because, the Z angle is the one that gives us the rotational aspect. Okay, so if you think of a plane, when it is rotating, right, it will always be in the same plane. But the Z-axis is the axis that points perpendicular to the ground, and the rotation happens around the Z-axis, right? So that's why we are saying ZYX, and we want the first angle. Okay, if you use a different notation here, if you say YZX, just make sure you do the second angle then. Okay. So if this is positive, right, then I want to set the power of the left side. I want to basically increment the power of the left motors and decrement the power of the right motors, right? So we'll say front left motor dot set power. And let's say we start off with the value of 0.3, and we'll say we'll increment it by a factor of 0.01. Okay. We'll do the same for the back left motor and front right motor. We'll instead decrement the power, and back right motor will also decrement the power. Okay. So the other case is else if it is less than 0, and we'll play a little bit with these values a little bit later. If it's less than 0, we'll do the exact opposite, right? So let me go ahead and copy these first. Instead, we'll decrement the power on one side and increment the power on the other side. And if we get an exact 0 value, we just want to set the power to be 0.3. Okay. And after everything is done, you basically want to set your power values back to 0. All right, I think we have everything. Let's go ahead and run our program. So we have initialized our motors. We have set the direction. We're saying, hey, go ahead and use the encoders. I think we got everything correct. We initialize the parameters for the IMU. We're initializing the IMU and then initializing the parameters. I mean, we're setting the parameters again for the IMU. We added some telemetry code to say press run to start. I think we should, it should be press start to run or something. So I'm not going to worry about that for now. Let's go and add some telemetry code here too, just making sure that, we are getting a positive angle or a negative angle, right? So that will be helpful for us. Let's say if it's greater than 0, and let's go ahead and print out the angle that we're getting. Heading angle dot, oops. Similarly, let's say just say negative. Okay. And finally, we want to say all right, let's go and run this program. So I called it IMU in class demo and group is IMU. Okay, so let's go ahead and put some variation, so randomness. Go ahead and show the path, and we'll go ahead and initialize. Cool. So that kind of shows you, yes, it's going in a straight line. Okay. And now let me go ahead and post this exercise. I think almost everybody should have their robot up and running, right? So some of the questions that you asked, Isabella, I think I would want you to try it, okay? So let me go and post this exercise. Isabella, I don't know if your system is set up yet, so maybe somebody else can try it and let's see how it goes, okay? All right. So I posted the code. You can go ahead and copy the code and see if it runs. So some of the things that we want to try out, right? One of the things that Isabella mentioned, can we increment change the power of only maybe the left motors, right? That's one thing to try out. The other thing is this angle, right? Is right now I'm saying my tolerance angle is 0 degrees, right? So change your angle to be, let's say, 2 degrees or 3 degrees and see how it works out, right? That's the other variation you can do. In the meantime, I'm actually going to do some refactoring. Let's do some refactoring here before you go ahead and start, okay? So I can see that, there is duplication here, right? So let me go ahead and create a variable called tolerance angle. So I'm going to say right click and say refactor. See if there's a create variable here, introduce variable. Let's say it says there are 6 occurrences. No, I want to replace only this occurrence, right? Because I do not want to replace all these two, okay? So let's say we'll replace only this occurrence and we will say it is the, oops. Okay. So this is also called tolerance angle, right? So if your heading angle dot first angle greater than tolerance angle, do this. else do this bit, else, I mean, if it's 0, do this bit, right? So there's another bit of refactoring I can see. You can see all these 0.3s are duplicates, right? So maybe I can create a variable called initial power or something like that. So let me click on that and say refactor and say introduce variable. And in this case, I want to replace all the 12 occurrences, right? Because they're all the same. Let's just call initial. Okay. So it's initial power plus 0.01. The other refactoring that we can do is because everywhere we have another duplication here. So let's go ahead and also refactor this and basically create a variable. So we'll replace all the 8 occurrences and say, all right, I think this code looks much neater. So now if you want to play with it, right, you will guess, like, let's say if you want the angle to be, let's say 5 degrees, you just have to change this, right? You don't have to go all through the whole code and change it, right? And also if you want to change the power increment, you can have only one place to change it, right? You don't have to go to all your specific lines of code and change it, right? So let me go ahead and post this refactored code so that it's available to you. And you can now take this and go ahead and start playing with it and make some of the changes. One of the change that Isabella recommended, and also go ahead and change the power of the tolerance angle and see how that works out, okay? Any question on that? Are y'all ready to go ahead and start playing with this code?
Yeah.
Cool, go ahead. And once you're done, you can go ahead and share your what you found out, okay? So 2 things, right? So the first thing is the question that Isabella said. So can we change power of one side? Right, and 2, maybe you can change tolerance angle and see. Okay, so those are the 2 things you can try. And once you're done, let me know, and maybe in the last 10 minutes, we'll talk about the homework assignment for this week, So while y'all try that, if there are any questions, I'll be happy to answer questions. And once you're done, you can maybe share what you found out to the class. You can do a share your screen and show everybody what you found out. All right, go for it. Is anybody's system not set up? Tyra, I know this is your first class. Do you need any help, Tyra, setting up your system? And Isabel, I'm not sure if your system is set up. I know you were off last week. So Alia will be able to help you. Alia has actually already completed the square exercise, by the way. So Supreet, I know you were having an issue last week. I'm not sure where you stopped, Supreet, about your system setup. We were able to fix Merlin's and Anya's system like on Thursday. So if you still have an issue with your system setup, let me know and then I can help you out while we are trying this exercise. Also, when you're trying the exercise, make sure you have that some randomness, by adding some inertia. I don't know what they call it, like inertia or systematic motor error or random motor error, right?
So Supreet says I had downloaded Java 8, but then we needed to end the class. So Supreet, do you need help with the setup?
Yeah, and you're very close to Preet, Yeah, you can go and share your screen, Supreet. I think we can get that resolved pretty quickly. So you have Java 8, I'm assuming, right? You said you have Java 8. The other thing is you probably have IntelliJ Community Edition. The third thing you may have to download is the zip file. And like Richard showed you, right? You basically go to Git, and then you can get it from Git. So let's see if I can find the link, or maybe I posted the link and pinned it somewhere.
I think you had posted the video, and
Okay.
the link is in the video.
I was thinking last time maybe I did this, Richa. Maybe not.
It could be that you use that in the Thursday session.
Hi, I'm Olivia from
But I have the link. I can post it in the chat. Did you find it, or do you want me to post it?
I can like do a Google, Richa.
It's okay. I'm posting the link.
Oh, you have it? Cool.
Yeah. Is Supreet going to share his screen, or?
So Supreet, you would need to go to that link, right? And click on this green button if you're seeing my screen. Then go ahead and download zip. And once you're done, we can take it to the next steps. Isabella, like the link that Richa shared, right? Go there and say download zip. And then maybe one of you can share, Supreet or Isabella, and we can kind of take it from there. So do download zip and expand the zip file. And once you're there, let us know.
Yes, download virtual robot Supreet. Yes, that's right.
All right, Isabella. Do you have the community version of IntelliJ, Isabella?
I'm not sure if I do or not.
Okay.
I think I did though.
Okay, cool. Let's see if maybe Anya or Alia, is that normally the community version? Do we go to prove? I'm not sure about Windows navigation, right? How do you navigate and see if the community version is available? Do you do start and can you go from there to see if IntelliJ?
So what are you trying to do? Sorry, I was focusing on the Java.
Sorry.
fine.
We want to see where if IntelliJ is installed, Anya. So I think last time maybe we used the Explorer.
We went to apps and then
Oh,
yeah,
there you go.
went in it.
Good job. Yep. You can say don't send. You can do skip and set defaults. Nice. I think open or import. And you want to choose the thing that you downloaded, Spilla, but don't click OK. Okay, just go and see if you can navigate to the folder that you downloaded, the robotics, the virtual robot, right? Whatever you just downloaded, the link that Richa just posted, right? Do you know where you put it, Isabella?
No, I don't know if I downloaded that link.
Okay, cool. Leave this open, okay? And then maybe go to the link that Richa posted on the Slack channel.
It's on the chat. I can post it on Slack too. Give me 1 second. There you go.
Go click on that green, yep, and then download zip. And 1 minute is like you want to make sure you expand. It's a zip file, right? So we want to extract the contents. So click on that and maybe it'll extract the contents, or at least it'll show you where it downloaded it, right? Say, yeah, show in folder. That's good. And is this expanded? Just see where it is in downloads and virtual robot. Can you click on that display? Like, yeah, let's go in and see inside. Double click on it. You can do open too, that's fine. Cool, I think we will basically, so it's in downloads folders, okay? So go back to your IntelliJ and say open. And we need to find where the downloads folder is in Windows. I think maybe it is under Windows. Let's see, Windows.
You can maybe look at it where the browser downloaded it, no?
Yeah, just it's the window just behind that IntelliJ. Let me see if I can request control, Isabella, okay? All right. C STM users, and it's right there. Okay, remember that as well. It's under users and STM2 downloads. Okay, so users STM2. Yes, you can take control back, and there's a downloads folder. Expand that and see if you can find the virtual robot folder.
Did you unzip?
I think she did, Richa. Virtual underscore robot dash master. Maybe you have to restart your or do a refresh on that. Go back to yeah. See, there's a refresh icon right there. It's at the All right, I think I still have control. Now see if you can find it. Nope, it's not there.
Can
Or
you
maybe
cancel? Yeah.
just restart IntelliJ maybe.
Yeah, let's just cancel out of this and then.
Redo this, right? Okay.
Yeah.
Yeah, do a cancel, Ms. Villa, and restart.
Nope. I think maybe I'll be looking into the wrong folder.
I mean, it's.
Alright. I'll have you go back to your, yeah, there again, and then go to your robot master for, okay, maybe go to downloads, that's fine. Go to downloads. And then can you right click on that and say,
Extract all.
no, I think it's already, yeah. And then extract, yep. Did it extract?
Yeah, let's try that. I mean, even if it's there, it'll override it, right? Just,
Right. Yeah, I don't think it was extracted wrong.
okay, that's
That's why
probably the
it
issue.
was finding it.
Okay. Yep, that's right.
Yeah, now it is there.
Cool.
It's
Go back to IntelliJ.
There you
Cool. Hold on, Isabel. Just before you do, okay. Expand that folder. Yeah, select that folder, the folder that's below, yep, that folder, yep, and now do okay.
All right.
Yeah, that was the issue Anya and Merlin were having, so. All right, you're all set. You can basically go ahead and click the run button right there at the top. It's on your top right, the green arrow. Yep. It may take a minute or two. All right, let's see if anybody else is having an issue in the interim. It's still compiling, I think so.
Is Suprit okay? I did not hear.
Yep, this is being recorded.
Is Suprit okay? Suprit, do you have issues? I did not hear back from you.
You can share, Supreet, maybe after Isabella is done, and we can see where you're. Okay, you extracted it. Do you want to share, Supreet, and maybe we can guide you? I think Isabella stopped sharing, so if you want, you can go and share your screen. Is this Supreet's screen that I'm seeing?
Yeah, this is my.
Yeah, I think let's do this, Supreet. So go to File, go to the File menu, and say Open. And can you expand that folder, Supreet? Yep. And then there is another virtual row underscore. Select the, yep, that, and say okay. Say new window. And now you should be able to run it, Supreet. Okay, you see the run button now?
Yeah, I see that.
Yep, now you can go ahead and run it. Does anybody else need any help? I think everybody else should be set up, as far as I remember. And does anybody want to go ahead and share their findings for the two things that we posted? maybe Gracie, Tejas, or Alia, do you want to base? Are you all done with trying any of these?
I have a question.
Yep.
Do I need to change part of the code to use the gamepad?
Yep, you do, right? Who's this?
Isabella.
Oh yeah, Isabella. So I think let me share my screen back. You can see my screen?
Yeah.
All right. Go to our Slack, Isabella. And I think I posted this on Monday, June 29th. Okay. If you scroll up a little bit, there is one change you have to make. Okay. You have to go to this file, source virtual robot config.java, and you'll have to change this line of code. Okay.
Do you think you could pin that?
Yep, I can pin it.
Okay, thank you.
All right. I think let me see if I need to pin this one. I'll fix this later. You know, I pinned a couple of things. Okay, so all right. Anya, your question about how to make it pretty again. Let me see. So Anya, if you look in IntelliJ, if you look at code, I think if you can see my screen, right? There's a code in the file menu, and then you can say code and reformat code. Okay, that will make your code look pretty again. Okay.
Okay, thanks. I just forgotten.
No problems.
Could I share my screen? I'm not sure
Yep.
where to put that code in.
Go for it. Yep, open up IntelliJ. All right. On your left-hand side, Isabella, like there is a project and structure. Like you just look on your left-hand corner at the top, okay? Yep, that's the one. Click on that. All right. Expand that folder called Virtual Robot. Yep. And then I think it's under, I think expand controller. I think it's under controller. Yeah, source, virtual robot, config, and it should be line 18. So change that from false to true. And you can go ahead and run it now, and your gamepad will appear. Okay. Cool. We're all set. So this code that I sent you, Isabella, the easiest way to do this, right, is go ahead and close this out. So now on your Explorer, right, go back to IntelliJ and go ahead and minimize the controller on your Project Explorer, like on the left-hand side, right? Yeah, minimize that, like, so you can click on that triangle over there so that it, yep, and expand team code, source, and yeah, you can expand that, but you can right click on that where you are right now, is right click on that and say new, the first one, it's all the way to the top, new Java class. And the easiest way to do this would be go to Slack and get the name of the class. Okay, go all the way down. And I think we called it a little bit up. We called it IMU in class demo, right? A little bit down. Yeah, go ahead and copy that class name, IMU in class demo. Yeah. And yep, and enter. And now you can go to Slack and just copy that whole file and paste it here. Yeah, copy everything and just do a Control A in IntelliJ and then paste what you have, okay? Control A on this and then just paste it. Cool, and now you should be able to run this. Go ahead and stop whatever you're running, Isabella. So go ahead and hit the red icon over there. Yep. And now you can run this, Cool. Now you chose Mechanim bot, right? Go ahead and choose our the program that we just put in, right? So go on your second drop down as well, right? Yeah, expand that on your op modes, yep, and see if you can find the IMU, yep, and say init. All right, now you can see it's like there's no, it's pretty much going in a straight line, right? Try to create some, go ahead and restart it and then try to add some disturbance, right? By basically, yeah, you need to do that, right? So you may have to restart the program, okay? Go ahead and restart it, yep. Go ahead and kill it and restart it. Up, yep, you want to select your op mode, yep. Now you see the angles, right? It's kind of going out of its path and then it's correcting itself, okay? All right, now you can go ahead and, did you already make the change as well? You didn't, right? So go ahead and play with the program a little bit, Does anybody else want to share the screen? I think we're close to time, so you want to be cautious of your time. You want to share the screen, discuss your findings. Tejas or Gracie, Alia, or Anya? If you're talking, you're on mute, Gracie. So the exercise for this week would be, I would want you all to do a controlled right turn using IMU. So on the click of the gamepad A or B, right, you can say, okay, if I click A, you do a 90-degree turn, but at every single point, you will see the current angle and keep changing the power until the angle is 90 degrees, okay? And once your angle is 90 degrees, then you can go on a straight line, okay? So you'll need to use the IMU sensor, right? And see if you can do a controlled left turn based on the amount of degrees you specify, or a controlled right turn, okay? Any questions for the homework assignment? And since we're almost out of time, you can also try out these two things, after the class, can we basically change the power of one side of the motors, and also can you change the tolerance angle, and see your robot's path, okay? All right, ladies and gentlemen, I think we're out of time, so feel free to Slack me if you have any questions. Before everybody leaves, if anybody wants to share their screen, kind of talk to those things, that'll be good. But if you're not there, that's fine too,
And just a reminder, go through the links for installing Git and also creating a GitHub account. We will try to save your code in GitHub next time.
All right. Thank you all. I will talk to you next week, and we will be looking at the PID controllers and the Vuforia. And unfortunately, on both of those, the simulator will not work, so it'll be theoretical is what I'm thinking, or we'll see how to do that, so you may, I don't know if you'll be able to practice it though, on the simulator, okay? All right, thank you. I will see you all next week.
Bye.
Bye.
And I'm still recording.